We are still evaluating logarithmic expressions. The next expression we have here is the logarithm of 1 all over 243 to base 9. How do we evaluate this? Same procedure. Log of 1 all over 243 to the base of 9. We'll say let this be equal to, what should we use this time? Let's say let this be equal to k. And again, convert this from the logarithmic form to an exponential form, or in this form. I say 9 raised to the power of k is equal to 1 all over 243. So I'll say 9 raised to the power of k is equal to 1 all over 243. Of course, if you look at this closely, you may not be able to see it very well. This is an exponential equation, of course. 243 is a multiple of 9. Yes, because 81 times, no, I think that will be multiple of 3. Right, multiple of 3. 81 times 3 will give us 243. And 81 is 3 raised to power 4. So 243 is 3 raised to power 5. So I turn this to 3 raised to power 5. I'm using 3 because I can also express 9 as a multiple of 3. So that gives me 3 raised to power 2. And then this is raised to power k. So from here, I can say, let's rule this. Now this is 3 raised to power 2k is equal to 3 raised to power minus 5. You will agree that 1 over 3 raised to power 5 can be expressed as 3 raised to power minus 5. And straight away from here, we can say that our 2k is equal to minus 5. Therefore, k is equal to minus 5 over 2. Hence, the logarithm of 1 all over 243 to base 9 is equal to what? Minus 5 over 2. Meaning that 9 raised to the power of minus 5 over 2 will give us 1 all over 243. You can try that out to see if it is true. Okay, let's see. Put this in liter form. Yes, let's go over this again quickly. Just hold on. Let's trying to get my pen to work. Okay, so here we are. 9 raised to power k is equals to 1 over 243. And of course, 9 raised to power 243 cannot be expressed as what? As 9 raised to power an integer easily, or rather, let's use 3. So we have 3 raised to power 5 as 243, and then we'll convert 9 to 3 raised to power 2, and that takes us to this level, and then we can then solve. We can finish this up as we did earlier on. Of course, we got there that our k is minus 5 all over 2. Our next question, we have to evaluate the logarithm of 0.00001 to base 10. This is still the same thing. Again, I simply say, let this expression, the logarithm of 0.000, how many zeros do we have there? 4, 1, equal to, let me use my x again, to base 10. Now this means that 10 raised to the power of x, as usual, 10 raised to the power of x will equal to what? 0.0001. And we have there as 0.00001. Change this to fraction, and that will give us 1 all over 10,000. Not 10,000 or sorry, that should be 5 zeros. So we have 10 raised to the power x there. And then this will mean 1 all over what? 10 raised to the power 5. This is 10 raised to the power x. Of course, we can write this out as 10 raised to the power x equal to 10 raised to the power minus 5, which means that what? Our x is simply minus 5. Hence, the logarithm of 0.00001 to base 10 is equal to minus 5. Sorry about the delay here. Wasn't too sure about this. So that's it for them. Here we have it again. 10 raised to the power m is equal to this. Of course, this will give us 10 raised to the power minus 5. Yeah. And we have it there. And the log of 0.001 is what? Is minus 5. The third one, or second to the last question, we have to evaluate the logarithm of 0.125 to base 4. Again, once you have a fraction, you must find a way to convert it to, sorry, decimal, convert to fraction. 0.125. I'll simply do this. This is over 1,000. And then play this out. If you divide this by 25, that should give us 5. You divide this by 25, that should give us 40. And that should play out to be 1 all over 8. So we can write this, that the logarithm of 0.125 to base 4, we can first of all break this down and write it as logarithm of what? 1 all over 8 to base 4. And then we'll start from here to evaluate. Let's say this is equal to y. Convert this to exponential form. That means 4 raised to the power y is equals to what? 1 over 8. So, okay, 4 raised to the power of y is equal to 1 over 8. Now we have it in exponential form. How do I solve? 4 and 8. The best number I can use there is 2. I turn this to 2 raised to the power 2. All raised to the power y will give me 2y. And this is 1 all over. 8 will be 2 raised to the power 3. Now write this out. 2 raised to the power 2y is equal to 2 raised to the power minus 3. Yes. Negative index. So now we have 2y is equal to minus 3. And our y is what? Minus 3 over 2. And that's the value of log of 0.125 base 4. So we write there, and the value of logarithm of 0.125 base 4 is minus 3 over 2. Alright, so that's the procedure. Again, you can see here, we could not express 1 over 8 as in terms of what? In terms of 4. So we had to advance and make use of 2. So we have 1 over 8 there as 2 raised to the power minus 3. That's 1 over 8. 2 raised to the power minus 3. So you have 2 raised to the power 2y to give you 2 raised to the power minus 3. And your 2y equals to minus 3. Because here we have left hand side equals right hand side. And of course, the two of them have the same base. Hence, the exponent must be the same. Y therefore is minus 3 over 2. Hence, the logarithm of 0.125 to base 4 is minus 3 over 2. There is a last question under the relationship between indices and logarithms. We are evaluating logarithmic expressions. We are evaluating logarithmic expressions. We are asked to evaluate the logarithm of the root of 27 to base 9. Shouldn't be scared of this. Again, let's just say, let this be equal to, let's use n. That means that 9 raised to the power of n must be equal to the root of 27. So I write this out in exponential form. 9 raised to the power of n is equal to what? The root of 27. First, I take off this root and write this in index form or index form. And I write here square root simply stands for what? 1 over 2, the fractional index. And I have here 9 raised to the power n. How do I express 27 and 9 to have the same base? The best bet there is 3. I can write 9 as 3 raised to the power 2. Of course, raise everything to the power of n. 27 can be written as 3 raised to the power of 3. Of course, everything again raised to the power of half, that is there. I'm sure we're following. Now I proceed. My left hand side becomes 3 raised to the power of 2n. Remember, our objective is to find n, which is what? The value of logarithm of root of 27 to base 9. Now this side again, the same thing. 3 times half will give me 3 raised to the power of 3 over 2. Now left hand side again is equals to right hand side. The two bases, they are the same, 3, 3. Therefore, the exponents must be the same. So I say that means my 2n is equals to what? 3 over 2. Dividing both sides by 2, I'll have n equals to what? 3 over 2 divided by 2 should give me 3 all over 4. Which means that the logarithm of root of 27 to base 9 is equal to 3 all over 4. Let's take this. Okay, consider 9 raised to the power n equals to what? 9 raised to the power n equal to 27 raised to the power half. Half representing the square root sign. Now change 9 to 3 raised to the power 2 and then write 27 as 3 raised to the power 3. Now multiplying 2 by n will give us 3 raised to the power 2n. And then on the other side, multiplying 3 by half will give us 3 raised to the power 3 over 2. And then, of course, equating the exponents, we have that 2n is equal to 3 over 2 there. And then solving for n, we have 3 over 4. So the logarithm of root of 27 to base 9 is therefore 3 all over 4. So that's it for evaluating logarithmic expressions. From the next video clip, we will now consider the laws of logarithms.